what are the different manufacturing options? Basically, we have three manufacturing options. And our system, the Ivoclar digital denture system, is now referred to as the iVotion system. A little bit confusing, so I'll try to clarify it. In the iVotion system, you have three methods of processing. So Rose Laboratories got the options to do any one of these three methods of processing. First, as we refer to as the artificial tooth process, and this is where the denture base is milled and the denture teeth are carded denture teeth, and then they are bonded to the milled denture base. So that's the artificial tooth process, and that was the first process that most manufacturers had started with. We advanced from there to what we refer to as an oversized process, and what this is that the denture, the base and the denture teeth are both milled about 80% of the percentage of milling, and then they're bonded together, and then we're put back into the mill for a final mill. It's a beautiful process. It's a patented process for this particular system, and what it results in is a two-part denture. The teeth are separate from the denture base. They're bonded together, and then they're final milled, which gives a beautiful finish to the denture and a very microscopic interface between the teeth and the denture base. So it's really an advancement in this particular part of the technology. What is very current, literally within the last several months, is this monolithic process where it's one disc, and it's a bicolored disc, and it's it creates, it has the pink and the white, and so the denture is literally a monolithic denture. And I did want to spend a few minutes on this particular concept because it is new and it is exciting. It is exciting. Each of these processes has pros and cons, and your choice of the process is based upon your particular clinical case. But I'm going to spend a little time with this iVotion disc because it is the newest kid on the block, as I mentioned. So again, it's got two pieces that are together, but the chemistry is that it's a seamless kind of chemistry. They're manufactured together, so they're not bonded. There's not an interface. There's chemically complete union. In other words, this is a solid block, and so we've eliminated the interface between the tooth-colored material and the pink. Your first question should be like impossible, but somehow this has occurred. Now, I have to admit, I wish I thought of this process, and when it was first introduced to me 4 years ago, maybe 5 years ago, I thought, oh, this is a fantastic idea, but impossible. But the geniuses that worked on this project, and that's all I could call them as geniuses, they developed this geometric concept. The way these are fabricated, the pink and the white aspects of the denture, again, they're not separate, but they're the geometry are these channels and these grooves, this shell-like effect that accommodates the positioning of denture tooth setups. And it's like a sliding scale that it accommodates a small arch to a large arch. And it allows for a significant amount of adjustment of individual teeth. There's a tremendous amount of design flexibility. And you just have to appreciate how this could possibly be and still turn out a denture that is flawless from the standpoint of the pink and the white. In other words, there's not tooth colored on the base, there's not pink on the teeth. The junction is a flawless junction, but the advantage is obvious that it's lithic as opposed to a two-part um, prostheses. And the aesthetics are quite good, very compatible aesthetics. So in summary, this is a monolithic denture. It is monolithic uniformity of strength. So you're trying to break this denture, it's all together. So you're not breaking teeth off a denture base, you're trying to break the denture. So it has a significant amount of strength. There's no bonding interface. There's a tremendous amount of flexible design options, as I mentioned. It is just as accurate, just as aesthetic, and just as predictable as other forms of manufacturing. And one of the beauties of all three of these processes, I might add, they're proven materials, not new materials. These are time-tested, time-honored polymethylmethacrylates. The denture tooth material is the same material. It's patented, but it's FDA approved. These are denture tooth materials that are put into this process. The denture base, same thing. There are denture-based materials that we've been using for the last, 30, 40, 50 years, whatever it's been. So they're cross-linked and the bases are hardened and et cetera. So excellent materials. They're time-tested and your experience with them should be very predictable.